All right, it's time for Chapter 6, Lesson 1. The learning objective A is I can write powers of products using exponents and find the product. So let's look at this vocab right here in the vocabulary startup. A product of like factors can be written in exponential form using an exponent and a base. The base is the number used as a factor. The exponent tells how many times a base is used as a factor. So we need to fill in the boxes with the words factors, exponent, and base. So we know the factors are the numbers that are being multiplied together. And this said the base is the number used as a factor. So that was 10. And the exponent is how many times the base is used as a factor. So it was twice. So this little 2 is the exponent. Let's skip down to the real world link. MP3 players come in different storage sizes, such as 2 gigabytes, 4 gigabytes, or 16 gigabytes, where GB means gigabyte. 1 gigabyte is equal to 10 times 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 10 bytes. So what is this number written with exponents? So we have 10 being repeated. How many times is it repeated? 10 would be the base. And the exponent is how many times it's repeated. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a little bitty 9 up here. 10 to the power of 9. Let's start the lesson. On the left, page 434, we're writing products as powers. And then on the right, we're going to write powers as products. So these are the two parts of learning objective A right here. Okay, so it says numbers expressed using exponents are called powers. For example, 100 is a power of 10 because it can be written as 10 to the power of 2. Numbers like 100 are perfect squares because they are the squares of whole numbers. So 10 times 10 is 100, and it's written 10 to the power of 2, or 10 squared. Perfect cubes are numbers with 3 identical whole number factors, such as 4 times 4 times 4 equals 64. So the number 64 is a perfect cube. So when you do 10 times 10 times 10 to get the volume, that's 1,000, or 10 cubed, or 10 to the power of 3. So let's write down what we say about about powers here. Powers. All right. So 2 parts. All of the factors are the same number. So let's write when all of the factors are the same number, we can write a power using a base and an exponent. So here's an example right here. 10 times 10 is 10 to the power of 2. This is the base. This is the exponent. All right, let's look at some examples here. So we need to write 6 times 6 times 6 times 6 using an exponent. It is, there are 1, 2, 3, 4 sixes, so that's a factor 4 times. 6 is the base, and then since it was 4 times 4 is the exponent. Write 4 times 4 times 4 using an exponent. So the factor 4 is the base. It's multiplied 1, 2, 3 times. So the exponent would be 3. So you write it with the base and the little exponent. All right, let's do these 2 examples. Can you do these on your own? What's the base for A? And then how many times? What's the exponent? 1, 2, 3, 4. What about B? What's the base? And then 1, 2, 3, 4, 5, 6, 7 is your exponent. All right, so now we're going to find the products. Remember, product is the answer to a multiplication problem. Answer to a multiplication. All right, here we go. To write powers as products, determine the base and the exponent. The base of 10 to the power of 2 is 10, and the exponent is 2. To read powers, consider the exponent. So the power 10 to the power of 2 is read as 10 squared, or 10 to the power of 3 is often read as 10 cubed. So those are the fancy ways to say when the exponent is 2, it's squared. When it's 3, it's cubed. Write 5 squared, or 5 to the power of 2, as a product of the same factor, then find the value. So the base is 5, the exponent is 2, so 5 is used as a factor 2 times. And 5 times 5 is 25. What if you have a decimal? Write 1 5/10 to the power of 3 as a product of the same factor, then find the value. So the base is 1 5/10. The exponent is 3, so 1 5/10 is used as a factor 3 times. So let's remember how to multiply decimals. First, do 1 5/10 times 1 5/10. Don't forget that little placeholder there. 1 times 5, 1 times 1, add. Take the decimal out twice, put it back in twice. So that gives us this first product right here, 2 25/100. But then you have to take that and multiply it by 1 5/10 again. So 5 times 5, 5 times 2 plus 2, 5 times 2 plus 1. That little placeholder, 1 times 5, 1 times 2, 1 times 2, add. Take the decimal out 3, put the decimal in 3. What did I do? I messed something up. Oh, 2 plus 1 is 3. Whoops. All right, so there you have it. There's the product. So it works. Okay, just don't forget how to multiply decimals, because when you come down here in the examples, you're going to have to multiply decimals. So you take the decimal out, you put it back in. Now let's remember how to multiply fractions. So write 1/2 to the power of 3, or 1/2 cubed, as a product of the same factor, then find the value. So the base is 1/2, the exponent's 3, so you use that as a factor 3 times. Now remember, multiply across. 1 times 1 times 1 is 1. Multiply across. 2 times 2 is 4. And 4 times 2 is 8. So there you have it. 1/8 is the product. Now, did you guys notice that there were these parentheses here? This is why there are parentheses. It says in example 5, the fraction 1/2 is set in parentheses to note that the entire fraction is the base. So it's not like 1 to the power of 3 over 2. It's 1/2 to the power of 3. Not that one. So that's why you see you don't want this, because then it would mean that. We want this whole 1/2 to be together, so it's separated with parentheses. All right, write each power as a product of the same factor, then find the value. So we have to do 10 to the power of 5. So that we have to write each power as a product of the same factor. You're going to do 5 of these. So 10 times 10 times 10, that's 3 times 10 times 10. Now, let's find out what the product is. So your first 10 times 10 is 100. So then you do 100 times 10. So you have to add another 0, so it'd be 1,000. Then you do another times 10. So 1,000 times 10, you add another 0, that'd be 10,000. 1, 2, 3, 4, 5. 10,000 times 10 would add another 0, so that would be 100,000. So this product is 100,000. Okay, now 2 1/10 to the power of 2. So that would be 2 1/10 times 2 1/10. Now what does that equal? This is where you have to do it out. Can you remember how to do the math? 1 times 1, 1 times 2, 0 for the placeholder, 2 times 1, 2 times 2, add it, 1 plus 0, 2 plus 2, 4, take the decimal out, put the decimal in, 4 41/100ths. All right, now 1/4 squared, or 1/4 to the power of 2. So 1/4, that base is going to become your factors, and we need it twice. And you multiply across, so it's 1/16. So 1/4 times 1/4 equals 1/16. So that's what we have to do. We have to be able to look at this and write a base and exponent. Then we have to look at a base and exponent, write it out, and find the product. Let's take a look at a little story problem on the next page. The zoo has an aquarium that holds around 7 to the power of 4 gallons of water. So about how many gallons of water does the aquarium hold? Well, 7 to the power of 4 is 7 times 7 times 7 times 7. And 7 times 7 would be 49. 49 times 7 is what you do next. Let's do that over here. So 9 times 7 is 63. 4 times 7 is 28. 9, 31, 34. So this right here is 343. And then we have to multiply by 7 again. So 343 times 7. 7 times 3 is 21. Oops. 7 times 4, 28, 29, 30. There's 21, 22, 24, which is the product that they got right here, 2,401 gallons of water. So that's how you have to do that. Let's do this STEM problem. Michigan has more than 10 to the power of 4 inland lakes. That's a lot of lakes. Find the value of 10 to the power of 4. So you use 10 4 times. We kind of already did this on the other page. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. You just add a 0 each time. So it would be 10,000 lakes. It has more than 10,000 lakes in Michigan. That's crazy. You're lucky to live there. All right, time for the guided practice. Don't forget, you want to partner up. So make that happen. The guided practice is 1 through 6. All right. Let's go ahead and do the first two and then check your answers. So it says write each product using an exponent. So do number 1 and 2. You need to find what the base is and find what the exponent is, and then check your answers. So 8 would be the base. 3 times 3 would be the exponent. Here 1 would be the base, and it's 1, 2, 3, 4, 5 times. So 5 would be the exponent. All right, in numbers 3, 4, 5, and 6, you have to write each power as a product of the same factor, then find the value. So you need to write it out, do the math, and then write the final product. So 1/7 cubed, or 1/7 to the power of 3. Go ahead and do that one, and then check your answer. All right, so I need 1/7 3 times. Multiply across, and then multiply across. So 7 times 7 is 49, and then 49 times 7. Now we did that up here. So I'm going to point a little arrow. We showed our work up here. 49 times 7 was 343. So that would be 343. Okay. Do number 4, 2 to the power of 5. Write it out and then do the multiplication. So let's check this. 2 times 2 times 2 times 2 times 2. Do I have 5? 1, 2, 3, 4, 5. Okay, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2 is 32. Okay, now we have a decimal. So 1 4/10 to the power of 2. 1 4/10 times 1 4/10. I need to write it this way to do it. Don't forget, take the decimals out and put them in at the end. All right, 4 times 4. 4 times 1 plus 1. Placeholder, 1 times 4, 1 times 1. Add it. Take the decimal out, put the decimal in. 1 96/100. Okay, time for number 6. Coal mines have shafts that can be as much as 7 to the power of 3 feet deep. About how many feet deep into Earth's crust are these shafts? So it'd be 7 times 7 times 7. That's what 7 to the power of 3 is. Go ahead and find that out. We just did that up here and way up there. So 7 times 7 was 49, and 49 times 7, what we did right there, was 343. So this is 343 feet. That's how deep into Earth's crust the coal mines can go. Let's move on to independent practice. Okay, for independent practice, we're doing 1 through 9. So for the first 1, 2, 3, 4, 5, 6, you have to write each product using an exponent. So you're going to have a base and a little exponent for all of these 6. Then for 7, 8, and 9, you have to write out each power as a product of the same factor and then find the value. All right, you can do it. It's just like what we did on the last page. All right, let's check our answers for the independent practice. 6 is the base, there are 2 of them. 1 is the base, there are 3 of them. 5 is the base, there are 6. 12 is the base, there are 2. 27 is the base, there are 4. 15 is the base, there are 3. Now, these got a little bit messy. 6 to the power of 4, so we use that factor 4 times. 6 times 6 is 36. 36 times 6 right here is 216. 216 times 6 is 1,296. And then a half to the power of 3, so you have 1/2 3 times. 1/2 times 1/2, I did that right here, is 25 hundredths. And then 25 hundredths times a half, right here, is 125 thousandths. So don't forget, take the decimal out, put it in. Take the decimal out, put it in. 1/8 to the power of 2 is 1/8 times 1/8, multiply across, multiply across. And that's how you do it. It's reflection time. All right, here's the Chapter 6, Lesson 1 reflection for writing products of powers using exponents and finding the product. What does 9 to the 3rd power mean? Fill in the numbers below and label factor, base, and exponent. So you need 9 to the 3rd power, put it in there, label where the factors, base, and exponent are in these boxes. And number 2, write products of powers using an exponent. So you have to write this with a base and an exponent for A, B, and C. Don't forget the parentheses for the fraction. And number 3, find the product of the following powers and show your work. So 4 to the power of 4, 2 3/10 to the power of 2, and 1/3 to the power of 3. Should be good to go.